In these on this last page, we're going to look at half-life now. And again, just as a reminder, half-life is 50%. Okay, so it's very similar to what we have before when we took 100%. This time we're decaying by 50%. We end up with that 50%, which is 0.5 in decimal form. Okay, you'll notice that these formulas are all the same as what we did in doubling. It's just that now we're talking about half the time instead of twice the time. So if a 750 milligram is an initial dosage of a certain drug, what is the what with a half-life of 12 hours? So what fraction, or we can also say what decimal, remember fractions and decimals are equivalent to each other, is left if the medicine was taken at noon and the current time is 3 p.m. So the time to cut in half, again, we need both of those things. We need the time to cut in half, and we need to know what that time period we're talking about is. So the half-life is 12 hours, and the initial noon to 3:30 is 3.5 hours. So in order to figure out what fraction we have, we're going to take 0.5, and then we have how much time is being asked for, 3.5, divided by how long it takes to cut in half, so 0.5 raised to 3.5 divided by 12. Looking just at Desmos, we have 0.5. We're going to use our exponent key. We have 3.5 divided by 12 gives us 0.82 is our fraction. So it's more than half because we haven't gone all 12 hours. So 0.82 is the fraction after 3.4 hours, 3.5 hours. I can say fraction left, I suppose, after 3.5 hours. Okay, how much is left in the system after 13.5 hours? Okay, so the amount of the dosage, the initial amount is 750. We're going to cut this in half, so just 0.5. And then we were doing this for 13.5 hours over 12 hours, which means I'm going to have less than half left in my system because we're going longer than 12 hours. So just for estimates, we know that 750 divided by 2 is 375. So 375 milligrams is half. We should have a little bit less than half if we're doing this for 13.5 hours. So we have 750 times our 0.5, and then we're going to raise that as an exponent to 13.5 divided by 12, and that answer should be less than half, which is half was 375. We end up with 343.88 milligrams. Okay, so now we want to estimate when the body, when there is 50%. So if there's 50% left, I'm not sure why this is moving on me like this. Back. Close to where it was. All right. So estimate when the body has 30% of the initial amount. So 30% of our 750 is going to give us 225 milligrams. So we're looking for when we're going to get 225. So it's got to be less than 13.5 hours. I'm sorry, it's got to be more than 30. It's got to go longer than 13.5 hours because we only have 343. We need to have less than that. So we got to go longer. So my first guess, I'm going to guess, just guess 20 hours. Again, we just need a starting point. And we end up with 236.24 milligrams. So my 20-hour guess was not too far off, but I need to go a little bit longer because I need to get down to 225. So I'm going to go for 25 hours. And when we calculate 25 hours, and again, all we're doing is changing our 13.5 to 25 in this case, and we end up with 176.98. So 176.98 milligrams. So that's too far. So I got to come back between 20 and 25. So let's just try 22 hours. 22 hours is 210.46. All right, so 22 hours, again, was a little bit too long, so 21 hours. 21 hours, excuse me, 21 hours gives us 222.98 milligrams. We know 20 hours was too much, so this is 236 versus 225, so that's 11 milligrams off, where here we're only about 3 milligrams off, actually less than 3, probably 2 milligrams off. So we know the best guess here is going to be 21 hours, right? So let's write an exponential function. Now what we don't have right now for our exponential function, our exponential equation, is a percent of change. Okay, so we got to use that rule of 70 first. And that rule of 70, so is going to give us the percent. 70 divided by the time it takes to be cut in half. And we know that this is decreasing by 12 hours, cutting in half in 12 hours. So 70 divided by 12 gives us 5.8%. So again, if we just take 70 divided by 12, we don't change this from a decimal to a percent, we just use this as is, so 5.8%. So our equation would be the amount equal to our initial amount, which is 750 milligrams, times 1 minus, because we're decreasing, 0.058 raised to the h to give us the number of hours. All right, this last one, if a population is decreasing by 5.1% each year, what is its half-life? So the half-life, again, is using that rule of 70. So 70 divided by 5.1% is going to give us 13.73 years to be cut in half. All right, so what fraction is left in 8 years? If we know that it takes 13.73 years to cut in half, we know that it's going to be more than 0.5 because 0.5 is that half. So time to cut in half we know is 13.73 years. The time from initial to 8 is our 8 years. So in order to answer this question, 0.5, we're going to take 8 over 13.73, right? And just typing that into Desmos again. So if we have 0.5, and we're going to use our exponent to raise to 8 years is how long we're looking for, divided by, it takes 13.73 years to be cut in half. So this answer should be greater than 0.5 because 8 is less than 13. So we get 0.67. So 0.67 is the fraction left after 8 years.